Hey everyone, and welcome back for another deep dive. Today, we're going to be looking at some really cool research in AI,
Oh, yeah?
specifically how to make LLMs better at reasoning.
Right.
You know, those AI systems that can write stories, poems, even code.
Yeah,
Well, this research is all about taking them to the next level.
exactly. And while LLMs have gotten so good at mimicking human language, there's always been this question,
Hmm,
are they really understanding what they're doing, or are they just good at pattern recognition and just memorizing stuff?
right, right.
This new research called Logic RL is tackling this problem head on by trying to teach LLMs how to actually reason logically.
Okay, so logic RL,
Yeah.
it sounds a little technical. Could you
Huh?
break it down for us? What's the core idea here?
Well, the core idea is to train an LLM to solve logic puzzles,
Okay,
much like we humans do.
interesting.
And the researchers use a very specific type of logic puzzle called knights and knaves puzzles.
Okay.
So imagine an island where everyone is either a knight who always tells the truth
Hmm,
or a knave who always lies.
I'm intrigued. I love a good logic puzzle.
Yeah.
But how does solving these puzzles actually translate to an LLM learning to reason?
Well, think about it this way. These puzzles force the LLM to use deductive reasoning. Okay,
Yeah.
it has to analyze statements, identify contradictions,
Hmm.
and then figure out who's telling the truth and who is lying.
Gotcha.
But the researchers didn't just want the LLM to get the right answer.
Right.
They wanted to see the process of reasoning,
Interesting.
like the steps it took to get to the solution.
So no shortcuts or lucky guesses allowed.
Nope. They actually created a special system prompt
Okay.
that tells the LLM to actually write out its reasoning. It's like saying, show your work. Don't just give me the answer. Tell me how you got there.
That's clever. It's like a teacher who wants to see the student's thought process, not just the final answer.
Exactly.
But wouldn't an AI still try to find shortcuts or memorize patterns if it could?
That's a great question. And that's where the format reward system comes in.
Okay.
This is where Logic RL gets really interesting.
Uh-huh.
They designed this system that rewards the LLM for actually showing those genuine reasoning steps.
Okay.
And then it penalizes it for trying to skip steps or take
So
shortcuts.
it's like a reward system for thinking deeply and methodically. I
Yeah.
like it. But how do they actually implement this reward system? Was it a lot of hand-holding?
Well, they use something called regular expression extraction to make sure that the LLM presents its reasoning in a very specific structured way.
Okay.
So it's all about making sure that the AI is actually following a logical process
Gotcha.
and not just trying to guess its way to the right answer.
Okay, so they've got this clever system for guiding the LLM's reasoning,
Right.
but did it actually work?
Well,
Did the LLM become a logic
the
whiz?
results were pretty remarkable. The
Yeah,
LLM got really good at solving those knights and knaves puzzles.
nice.
But what's even more interesting is that it was able to actually generalize that reasoning ability to other tasks.
Really, so it wasn't just learning how to solve one specific type of puzzle.
Right.
It was learning something more fundamental about logic and reasoning.
Exactly.
Wow.
They tested the LLM on these challenging math benchmarks like the AIME and AMC. Those are high school level math competitions. And it actually did significantly better than its base model.
Wait, so it was able to apply its reasoning skills to math problems, even though it was mostly trained on logic puzzles. That's incredible. It almost sounds like it learned how to learn.
Yeah, that's a great way to put it. It really suggests that Logic RL isn't just about teaching specific skills.
Hmm.
It's about developing more general reasoning capabilities that can be applied to lots of different areas.
I'm really starting to see the potential here. This
Mhm.
isn't just about AI solving puzzles.
Right.
It's about AI learning to think more like us,
Mm-hmm.
to reason and solve problems in a more human-like way.
Exactly.
That's a topic I definitely want to dig into more.
Okay.
But before we do, I'm curious about the LLM's learning process itself.
Sure.
Was there a certain point where it like suddenly clicked, like a ha moment?
That's interesting.
Yeah.
There wasn't a single eureka moment.
Huh.
The research suggests that the LLM's reasoning skills actually developed gradually,
Okay.
much like a human learner.
So it was a process of continuous improvement,
Yeah,
building upon its previous knowledge and experience.
exactly. And this gradual development is, in a way, even more remarkable. It kind of suggests a deeper level of learning,
Yeah.
a more nuanced understanding of those underlying principles of logic and reasoning.
This is all fascinating stuff, and I'm eager to hear more about those potential implications you mentioned.
Okay.
But before we get into that, I want to take a closer look at those specific training methods they used.
Oh, right.
They were using some kind of reinforcement learning, right?
Yes,
Can you walk us through that a bit?
absolutely. They're using a type of reinforcement learning algorithm called reinforce plus plus,
Hmm.
which they found to be super effective for this task.
Okay.
They actually compared it to other algorithms like GRPO and PPO.
Hold on a second. Before we go any further,
Yeah.
Can we decode those acronyms for our listeners who might not be fluent in AI jargon?
Of course. GRPO stands for Group Relative Policy Optimization,
Okay,
and PPO is short for Proximal Policy Optimization.
got it.
These are different approaches to training AI agents using reinforcement learning.
So it's like comparing different coaching styles to see which one brings out the best in the AI athlete.
Aha, that's a great analogy.
And Reinforce Plus Plus emerged as the winning coach in this case.
Yes, they found that Reinforce Plus Plus was the most stable and efficient algorithm for this specific task.
So Reinforce Plus Plus was the champion. But did they have to make any modifications or to it to make it work even better for this challenge?
They did. They incorporated some interesting modifications to really boost its performance.
Okay, like what?
Well, including something called KL loss,
Okay.
which helps to prevent the LLM from straying too far from a reference model during training.
KL loss. Can you explain that a bit more?
Sure, KL loss is basically a way of measuring the difference between two probability distributions.
Okay.
In this case, it's used to make sure that the LLM's learning process stays on track
Uh-huh.
and doesn't diverge too much from what's considered optimal.
So it's like having a guardrail to keep the LLM's learning process from going off the rails.
Exactly.
That makes sense.
Yeah.
And what about the other modification?
The other modification they used was an unbiased KL divergence estimator,
Okay.
which helps to further stabilize the training process.
Gotcha.
It's all about fine-tuning the algorithm to make sure the LLM is learning in a consistent and controlled manner.
Okay, I'm getting a real sense of the level of detail and precision that went into this research.
Yeah.
It's like they carefully orchestrated every aspect of the LLM's training
Mm-hmm.
to maximize its reasoning abilities.
Right.
But I'm curious, did they try any other training approaches besides Reinforce Plus Plus or?
Yes. They also looked at a method called curriculum learning,
Okay,
where they gradually increase the difficulty of the tasks they give to the LLM.
curriculum learning, that makes sense.
Right.
Start with the basis and then gradually ramp up the complexity.
Yeah.
Did that give the LLM a significant edge?
It actually didn't provide a huge advantage.
Hmm.
They found that a mixed difficulty approach where the LLM sees all difficulty levels at the same time turned out to be just as effective.
Wow, so sometimes throwing the AI into the deep end, so to speak,
Yeah,
can work just as well as a more gradual approach?
it seems that way.
That's fascinating. It challenges our assumptions about how we need to train AI.
Right.
It's not always about cobbling it during training.
Uh-huh.
But I have to ask, how did they actually measure the LLM's progress?
Yeah.
How could they tell if its reasoning skills were actually getting better?
They tracked several metrics throughout the training process,
Okay,
but one that really stands out is something called the local inconsistency-based memorization score,
okay.
or LIMEM for short.
LLM,
Mhm.
yeah. That's quite a mouthful.
Aha, yeah.
Can you break that down for us? What exactly does it measure?
Essentially, LIMEM quantifies how much the LLM is relying on memorization versus true generalization.
Okay,
Remember how we talked about the risk of AI just memorizing patterns instead of actually understanding the logic?
yeah.
A LIMEM helps to expose that kind of like superficial learning.
So it's like a lie detector test for the LLM.
Yeah,
Revealing whether it's genuinely understanding things or just faking it.
exactly.
That's a pretty ingenious way to assess the quality of its learning.
Uh-huh.
But what did they find?
Well,
Was the LLM a champion of generalization or a master of memorization?
the findings were interesting.
Okay,
They compared their RL approach to a more traditional method called supervised fine-tuning,
okay.
or SFT.
Hold on, SFT.
Yeah.
Another acronym?
I know, sorry.
Just to make sure everyone's on the same page.
Right.
Can you remind us what SFT is all about?
Of course, supervised fine-tuning is basically a way of training a pre-trained language model using labeled examples.
Gotcha.
So it's like showing the LLM the right answers and guiding it toward those answers.
Okay, so it's a more direct approach to teaching compared to the figure it out yourself style of RL.
Exactly.
So what happened when they compared these two methods?
Okay.
Did FFT live up to its name and deliver superior fine-tuning?
Interestingly, not quite all. The results actually showed a clear advantage for RL when it came to generalization.
Oh, really?
Yeah, while SFT did improve accuracy, it also led to a really quick increase in that LINEM score,
Okay,
which suggests that it was mainly just learning the format of the answers
gotcha.
rather than the actual reasoning behind them.
So it seems like SFT was more about rote learning.
Yeah.
While RL really encouraged the LLM to think for itself. I love how this research kind of challenges our assumptions about AI training.
Oh, wait, someone wants to join. Hey, go for it.
It seems that we talk a lot about the idea and the result. Can we just go through the QA question, the research question.
Yeah, I think that's a great idea.
Let's do it.
So you want to dive into the nitty-gritty.
All the modifications and... Oh, go for it.
Just go through the research questions one by one.
Okay, I can definitely do that for you.
Yeah, we can go through those research questions
So you can see exactly what the researchers were trying to figure out.
and how they went about answering them.
The first one was about those RL algorithms we mentioned.
Reinforce plus plus and those other.
Right. The question was,
How does GPO compare to other RL algorithms?
in terms of training, stability, speed, and accuracy.
And the answer was reinforce plus plus was the most stable,
Yes,
but PPO achieved the best accuracy and reward.
exactly.
What was the next question?
Whether thinking tokens and language mixing matter.
Can you remind us about the thinking tokens?
Words like verify or reevaluate. The researchers found that responses with those words,
Scored higher.
yes, while language mixing decreased the ability to reason.
That's interesting.
It is.
So what was the next question?
RQ3 was about an aha moment.
If there was a sudden moment.
Right, but complex reasoning did not abruptly emerge.
It is more of a gradual development.
That's right.
And RQ4,
Super O generalization.
can you remind me?
How well the model could perform on new data.
Right.
It was exceptionally strong.
Awesome.
The next question was SFT versus RL.
RL is better at generalization.
Correct.
And the last question,
Number 6 was about curriculum learning.
gradual increasing difficulty.
Yeah.
It doesn't provide a huge advantage.
Yeah, it wasn't necessary.
Digging into these questions.
Mm-hmm.
It gives me a much clearer picture.
It does.
So do you want to talk more about their implications?
Sure do.
We wanted to talk about all of this.
Yes, exactly.
Now, think about solving complex problems.
Climate change.
AI could personalize learning.
Exactly, to your needs.
That is awesome.
That's right.
Let's also talk about limitations, of course.
Yes, a small data set.
So the researchers need larger data sets.
Indeed. And ethical implications, of course.
AI decisions need careful scrutiny.
Yes, responsibility is key here.
There were so many cool research ideas.
Making LLM responses shorter?
Like a clear blog post.
Yes, so people will read.
Also stabilizing RL training.
Training smart, distractible puppies.
Always a challenging balance.
Better training methods are key.
What about language reasoning?
Multiple languages, unlocking intelligence.
Like a deeper world understanding.
That's the hope and the dream.
Should we loosen the constraints?
Give LLMs freedom to learn, of course.
Exploring new methods.
Encouraging AI to be creative.
In a responsible way.
It is about balance.
Wow, this whole study's been insightful.
It really has.
But we never scratched the surface.
That's right, so much to say.
So key takeaways. Logic RL is incredible.
Exactly. Focus on understanding and reasoning.
Remember all of the concerns we said.
Research early and needs work, of course.
Now we have the final reminders here.
With these powerful new technologies.
All of this will make the world better.
With these tips, I think that is all.
Yes, and thank you.
Thanks for joining us on the show.
You're welcome always.
I hope you enjoyed it.
I hope you tune in next time as well.
Any then.
I can't wait. It was fun.